So of course, we are interested in looking at the Fourier transforms of the two images, the left and right image of the spots. So let's look at the Fourier transforms of those images. For this image, this is the Fourier transform. It does have a little bit of a dominant structure, but as you notice, it's got a lot of spectral frequencies distributed around it because it does have, while it has repetitions in X and Y, it does have a distribution of this thing because it's not the most structured image. Similarly, for the other one, of course, here you notice it should have more frequencies. These are larger objects or larger spots. These are smaller spots. When you have smaller spots like this, you expect the frequency diffusion to be much thicker, and of course it does have the directions but not as strong as in this one. So of course this has more frequency, this has less frequency in it. So continuing to look at the same two examples of the Fourier transform of this, the left and the right spots here, we have these two different frequency spectra. We can compute those. So we would compute the Fourier transform. Here I say FFT, which is the fast Fourier transform, which is in this and so far the same thing. And this is the left image, which gives us FL. And similarly, we do this for the right image and we get an FR. What we can do now is actually, again, if you recall from the last lecture, we can decompose this into different frequency spectra. So we can take the left image and break it into its F1, F2, F3, all the way. And we can do the same thing for the right image, F1, F2, F3, F4. And that gives us another whole set of information that is actually now separated out into its different bands. Now to help us generate these images, what we can do is we can feather corresponding octaves. Now I know I haven't covered the concept of feather. I'll talk about that in just a few seconds. But what actually we want to be able to do is feather. That basically in essence means is we want to kind of merge the right kinds of things from two different images. We want to do this now in the frequency domain. So we want to take the frequency, the Fourier transforms of the left and the right, and we want to do the corresponding octaves. Remember the F1, F2, F3, F4 for the left, and then the same for the FR. But we want to do the combination of the F1 for the left and the F1 of the right and do a feathering between them and do it for each and every one of them and then use that to reconstruct the signal. So in essence, what we want to do is we want to compute the octaves, feather them, and then compute the inverse fast Fourier transform. And that will allow us to feather everything in the frequency domain, and actually the output would be in the spatial domain. So now what we can do is basically sum the feathered octave images in the frequency domain, and we would actually have a very nice smooth image. Let's look at that example.